Hello, and welcome to the Open Systems Media webcast, MISRA C 2023, What You Need to Know. This webcast is sponsored by Parasoft. My name is Rich Nass, and I will be your moderator for today. I am also the Executive Vice President of Open Systems Media. I lead the content team for embedded computing design. If you're not familiar with that property, you'll find it's a great resource for anything related to the design of hardware and software for embedded systems. You can find it at www.embeddedcomputing.com. It's filled with design articles, white papers, blogs, videos, podcasts, and lots more. On this webcast, you'll be learning about the structure of the MISRA C standard and the role that it's played by the supporting documents. You'll also get to see a demo showing code compliance to MISRA C 2023 in a CI/CD workflow, and that's continuous integration, continuous development, if you're not familiar with that term. You'll get all that information from three of the industry's leading experts on this topic. They are Miroslav Zielinski, a director of product management, Michael Rosenau, a project lead for software engineering development, and Ricardo Camacho, a director of regulatory software safety and security compliance. They are all with Parasoft, and they will not be in the order that I just read them off, but you'll figure that out when we get there. Before I bring out our experts, let me go over some of the housekeeping items. This entire presentation from the guys will take about 35 minutes, and that'll leave us some time at the end to answer your questions, and we'll answer as many as we have time for. On the right-hand side of the console area, you'll see an area where you can ask your questions in real time. And we'll answer as many as we can when we're done here. If we do not have a chance to answer your question, one of our experts will get back to you after the webcast is over via email. If you have a question pertaining to the operation of the webcast, like the slides aren't advancing right or the audio doesn't sound right, put that into the question box, and one of our technical experts will get back to you with a fix. On the left-hand side of the console, you can see the full bios of the speakers. I didn't read them in the interest of time. On the left side, there's also a tab where you can download a copy of the slides that are being presented today. And there's also two white papers from Parasoft pertaining to MISRA C that you can download if you so choose. The first is a practical guide to accelerate MISRA C 2023 compliance, and the second is called How to Accelerate MISRA C Compliance. This webcast will be available in archived version shortly after we're done, so if you missed something, if you want to go back and review, you want to send it off to a friend or a colleague, it'll be there for you. Finally, a reminder that all Open Systems Media webcasts are copyrighted and may not be recorded without prior permission. Okay. That's enough for me. Let's bring out our experts and get this party started. Ricardo is the first one up. All yours, Ricardo. Take it away.
Welcome, everyone. My name is Ricardo Camacho, Director of Regulatory Safety and Security Compliance, and thank you for joining us today on this presentation to go over the MISRA C 2023, What You Need to Know. This is going to be not just a very informative presentation, but a valuable one because of the great content that we're going to have and the demonstration. The presenters are Miroslav Zielinski, Director of Product Management. Say hello, Mirek.
Hello, everybody.
And Michał Rosenau, Project Lead and member of the MISRA C and C++ Working Group.
Hello, it's a pleasure to be here.
Thank you both. Also, just to put Parasoft into broader context, we provide a suite of software test automation tools to help automotive organizations satisfy safety and security compliance requirements as defined in ISO 26262 and ISO 21434. All right, let's take a look at the agenda. First, Mirek is going to lay out the playing field by giving us a glimpse overview of the MISRA C standard, how amendments, corrigendum, addendums, permits, and compliance all fit in, giving us the big picture. Then Michał, our MISRA resident expert, will go into the details of what you need to know about MISRA C 2012 Amendment 4. We will then hand it back to Mirek, where he will place the latest MISRA C 2023 publication announcement in the picture. and give us a demo on how to integrate MISRA C 2023 static analysis into your modern CI/CD development workflow. I'm also very excited about this presentation because we are very proud of the fact that our latest C++ Test 2023.1 product release fully supports MISRA C 2023 and MISRA C 2012 Amendment 4. And on top of that, we also support a draft version of MISRA C++ 22X. I anticipate an announcement of MISRA C++ 2023 by the end of the year, but that's a slightly different topic from today. Anyway, after Mirik's demo, I'll do a quick summary and we will open things up for live Q&A. All right, let's get started. Handing it over to you, Mirik.
Thank you, Ricardo. So let's talk about MISRA. MISRA C is by far the most popular selection of the coding guidelines used in the industry for developing safety and security critical applications. It is widely adopted in all the verticals, starting from the automotive, going through aerospace and defense, medical, ending on the industrial automation. With the recent publication of MISRA C 2023, many organizations ask what it means to them. Is this a new standard with a new set of guidelines, or just a continuation? How much extra effort will it require to implement the new compliance process? In this webinar, we will try to answer some of these questions. We will explain what is MISRA C 2023, how is it related to the previous revisions of the standard and to supplementary documents. We'll do a quick review of the new guidelines, including some examples. And at the end of our session, we'll go through a quick demonstration showing how static analysis tools help in MISRA guidelines enforcement. So, what is MISRA C 2023? It is a second revision of the MISRA C 2012. The document itself does not introduce any new guidelines. It is a consolidation of MISRA C 2012 with its subsequent amendments and corrigenda. Specifically, it includes all the new guidelines introduced with recently published MISRA C 2012 Amendment 4. We will focus on Amendment 4 guidelines in the second part of this presentation. But before we do it, let's take a closer look at how MISRA C 2023 relates to the standard supplementary documents. And throughout the years, MISRA C, specifically MISRA C 2012, was augmented with the following additions. There were 4 amendments, 2 technical corrigenda, 3 addendums, 1 document with permits, and 2 documents about the compliance process and reporting. Each of these documents extends the core standard. Technical corrigendums and amendments 1 to 4 are now consolidated with the core MISRA C 2012 into MISRA C 2023. So, if someone asks what guidelines I must follow to comply with MISRA C 2023 fully, the answer is all the guidelines from MISRA C 2012 and those introduced in amendments 1 to 4. Addendums, permits, and compliance documents continue to be separate. In our session today, we don't have enough time to dive deeper into this document's content, but we would like to do a quick walkthrough to help understand the relation to the core standard. And let's start with addendums. Addendums provide mappings between MISRA C and other coding guidelines. So far there were 3 addendums released. The first one contains mapping to MISRA C 2004. The second one contains mapping to Secure C. And the third one is focused on the Cert C. Addendums are very useful when you have a business requirement to comply with more than one coding standard, or when you're migrating your compliance process from MISRA C 2004 to MISRA C 2012 or MISRA C 2023. With addendums, it's easier to understand the delta between standards and decide whether additional guidelines should be added or whether MISRA C 2012 or C 2023 alone is sufficient. And of course, all the addendums released so far are relevant for MISRA C 2023. The IDs of the guidelines have not changed, so all the mappings are still valid. Then we have MISRA permits. MISRA permits are very helpful when deviating from the standard. The MISRA permits is a document containing common use cases, say typical code constructs in the context of specific rules when deviating from the standard may be acceptable. MISRA permits are not blank permissions to deviate. The final decision must be always made in the context of specific project. Deviation permits shall be evaluated and negotiated, preferably at the beginning of the project. MISRA permits provide a lot of information regarding deviation reason, background, and requirements. This predefined information highly simplifies creating deviation reports and save a lot of time and money in the compliance process. Users, of course, can also create their own permits, and in many projects we've seen MISRA permits used as some kind of golden patterns for creating local deviation permits. And MISRA C 2012 permits continue to be acceptable for or applicable for MISRA C 2023. There were no changes in the guidelines that would invalidate these permits in any way. And another supplementary document is the MISRA compliance. The MISRA compliance document clarifies or defines what does it mean to comply with MISRA. It lists the fundamental elements of the compliance process. It defines the deviation procedure. It provides the guidance for potential guidelines recategorization. And it gives examples of reports that should be compiled in order to claim MISRA compliance. The important note here is that starting from the Amendment 2, the guidance provided in the compliance document is obligatory for MISRA C 2012 and what follows MISRA C 2023. So if your compliance process does not conform yet to the requirements of the MISRA compliance document, maybe introduction of MISRA C 2023 is a good moment to consider it. And then we have technical corrigendum documents. They are released to fix issues reported by the standard adopters. The primary purpose is to provide additional clarifications for the guidelines descriptions, additional exceptions for rules and directives, and in a few cases, changes in the guidelines categories. So we're talking here about minor fixes in the guidelines text, as well as essential clarifications related to, for example, guideline application, like an explanation of whether a rule applies to variadic functions or not. So far for MISRA C 2012, we had 2 corrigendums released. The last one was published in March 2022. The content of the technical corrigendums is typically integrated into subsequent revisions of the standard, what actually happened in case of MISRA C 2023. And finally, we have amendments. Amendments typically substantially update the standard, including new rules and directives. So far, we had 4 amendments released. Amendment 1 provides additional guidelines for security. Amendment 2 was an initial attempt to extend the standard for the new versions of the C language. Amendment 3 continued this focus, bringing more guidance to enable the safe use of modern C language features. And Amendment 4 is the last amendment. It was released in March 23. It brings even more guidance to enable the safe use of modern C language features. And here is where I stop and pass over to Michał to give you a more thorough overview of Amendment 4.
Thank you, Mirek. So now let's focus on the Amendment 4 to the MISRA C 2012 coding guidelines. As it was already mentioned, the main subject of this document is to provide guidance on the safe use of the thread and atomic standard libraries introduced in C11. It finalizes MISRA C working group work on support for C11 and C18, which started with the Amendment 2 in 2020 and has been continued with the Amendment 3 published last year. It's worth to mention that the only C11 features, use of which are not allowed by the MISRA guidelines, are now bound checking interfaces from the Annex K, which are not widely implemented and are considered to have significant flaws. So now let's dive into the contents of this new document. So what's new in Amendment 4? The main subjects of this document are thread and atomic libraries introduced by C11. The amendment allows now to use them, provided that all the new MISRA rules related to these features are being followed. Additionally, Amendment 4 provides additional guidance on the use of some of the older features of the C standard, such as small integer constants, unused objects, chained initialization, and variably modified arrays. Amendment 4 brings 3 new directives and 19 new rules, which means that we currently have the total number of 221 guidelines in MISRA C 2023. Additionally, 17 existing rules have been amended by this document to clarify or improve their definition. Now, if we look at the rule categories, Amendment 4 adds 5 new mandatory rules, which must be followed in order to claim the project to be MISRA compliant, which means we currently have 24 mandatory rules total. It also adds 13 new required rules that may be violated when supported by appropriate deviation procedure, and 1 new advisory rule that does not require formal deviation procedure for violations. Most of the contents in the document are related to the threads library and cover usage of thread objects, mutexes, condition variables, and thread-specific storage pointers. All 3 new directives and 11 out of 19 new rules relate to this topic, including 3 out of 5 new mandatory rules. And now let's have a look at some of these new guidelines. Amendment 4 introduces mandatory rule 22.12. It disallows direct reads and writes to be performed on the thread objects, mutexes, condition variables, and thread-specific storage pointers. Appropriate functions from the standard library shall be used instead. This code is non-compliant as it makes an explicit copy of the mutex object and compares thread objects using comparison operator. The compliant version uses pointer to mutex to keep a local reference to the mutex object and uses thread equal standard library function to compare two thread objects. Other two mandatory rules on threads enforce proper initialization of the thread synchronization objects and thread-specific storage pointers. This code is non-compliant as it uses mutex object M and thread-specific storage pointer key without prior initialization. Compliant version properly initializes mutex using mutex init function and creates thread-specific storage pointer using TSS create function. Please note that the rule uses generic terms shall be initialized before being accessed, without enforcing specific pattern on how this shall be implemented. It is a good practice to perform initialization in the program startup phase, but the rule does not require that, which means that, for example, initialization of the mutex object from main program thread when some other threads using this mutex are already running does not have to be a violation of this rule if it can be proven that the initialization is done before the mutex is ever accessed. Such nuances and freedom to use various design strategies to implement the code make 10 out of 11 thread rules to be undecidable and requiring system scope analysis. Only one new thread-related rule is decidable and enforceable on the single translation unit scope. It is Rule 22.13, which disallows objects of certain types to have automatic or thread storage duration, which rules out the possibility of accessing them outside of their lifetime. This code is non-compliant because it creates thread and mutex objects with automatic storage duration, which introduces possibility of undefined behavior in case a thread that uses them outlives the duration of function f. Compliant version creates these objects with the static storage duration, which means they can be safely accessed during the whole program lifetime. The second topic covered by Amendment 4 is related to atomic type qualifier. It allows to avoid data races when accessing objects from multiple threads, but atomics need to be used with care. That's why one of the new rules on this topic is mandatory rule 9.7, which requires proper initialization of atomic objects. This code is non-compliant because it assigns value to I variable without prior initialization, and it tries to read the value from the uninitialized variable j. Note that j was not given any value at all in this code. Compliant version properly initializes both atomic objects. I is initialized by providing a value on declaration, which also initializes all the facilities that serve atomicity of the object. And j is initialized using atomic init function from the standard library. Amendment 4 adds also 4 rules covering different aspects of the C language, which apply also to the older language versions. There is an advisory rule that restricts unused object definitions, which supplements existing rules from the unused code section. There is a rule that restricts use of small integer variants of the minimum width integer constant macros, which may behave unexpectedly. There is a rule that ensures consistency in using chain designators in initializers. And there is one mandatory rule 18.10, which disallows using pointers to variably modified array types, as they give false sense of type safety, while in fact they bring additional possibilities of falling into the trap of undefined behavior. Finally, Amendment 4 brings 3 new required directives in the new section called Concurrency Considerations. First, covered data races, which means that there are 2 conflicting non-atomic actions in 2 threads, and neither of them is defined to happen before the other. The second one covers deadlocks, which occur when two or more threads are waiting on each other. And the third one restricts dynamic thread creation by requiring to have all threads being created in the well-defined program startup phase. This example code contains definition of two threads which use non-atomic global variables G, H, and I. First, we will analyze potential deadlock, which is covered by Directive 5.2. Assume we have thread T1 being executed and it logs mutex H. Next, another thread T2 starts its execution and logs mutex G. Now, if the thread T1 continues, it will call incg function, which tries to synchronize on mutex G, already logged by T2, so it waits. And thread T2 calls getH function, which tries to synchronize on mutex H, already logged by T1, so it also waits. The program ends up in a deadlock situation as both threads wait for each other to release a mutex. Now let's consider potential data race covered by Directive 5.1. Assuming that the described potential deadlock did not happen, or the code using G and H variables has been improved to avoid deadlocks, we have a situation when there are two writes to a non-atomic variable I from two threads without any synchronization mechanisms. That constitutes a data race. It is undefined behavior, and assuming I is a 16-bit integer and the actual store operations on the machine are done for each byte separately, this may result in quite unexpected values to be stored in I after both operations finish. So now that we know better the contents of the Amendment 4, questions arise. Is this amendment really important to me? And shall I consider adopting it in my project, which is currently developed using MISRA C 2012 guidelines? Well, since the title of the document talks about the new C11 and C18 features, specifically threads and atomics, the answer surely is yes if you develop your code using C11 or C18. But even if you still write your code with conformance to C90 or C99, the Amendment 4 is still relevant, as 3 new guidelines apply to C99, and one of them applies also to C90. And note also that the new MISRA document additionally improves several existing guidelines, which you already use. So the answer for the question is yes, also if you still use C90 or C99 in your project. And now I will pass back to Mirek.
Thank you, Michał. Great overview. So, before we see the demo, let's think for a moment what are the essential requirements for the MISRA compliance tool. If we want to enforce compliance with MISRA, the first thing is that tool should provide 100% coverage for the standard. If we also need to comply with functional safety standards such as ISO 26262, we must qualify the tool. TÜV certification, if available for the tool, highly simplifies this process. And finally, a very important aspect is the close integrations with the modern development workflows. Most of the teams these days use some kind of CI platform. And teams don't want to change their workflows. They expect that tool will seamlessly plug into their system. And this is why it's so important that static analysis tool can be easily integrated into the modern development workflows and platforms. In our demonstration, we will see how you can add MISRA C 2023 compliance to your CI-based development process. We will see a simple scenario with the developer working on a new code in a feature branch. For the demonstration, we'll use a Linux workstation with VS Code and Parasoft C++ test, and GitHub with workflow that includes MISRA C 2023 Quality Gate. During the demonstration, we'll go through the following steps: creating some new code in the feature branch, running a quick pre-commit static analysis session focused on the most obvious problems, creating a pull request in GitHub, which will trigger a pipeline with MISRA Quality Gate, and updating the code to meet the pull request Quality Gate requirements. So let's switch to my development workstation. I'm using VS Code, and I already have a local clone of my GitHub repository here. My project requires MISRA C compliance. I'm working on a feature branch trying to implement new functionality for my system. One of my tasks is to make my so far single-threaded system multi-threaded. And I'm thrilled that with Amendment 4, I now have coding guidelines that will help me to make my project multi-threaded. My compliance process includes 2 steps: quick local scans with limited selection of MISRA checkers focus on the most critical problems, and complete enforcement of the MISRA C 2023 guidelines integrated with the GitHub pull request workflow. I have a dedicated configurations for both steps. So let me now pretend I'm doing something useful, and I will add new code to my feature branch. Let's say I need to implement new code which will handle periodic reading and calibration from my temperature sensors. To make our demo swifter, I've already implemented those changes. So let me uncomment relevant sections. I've implemented required functionality in 2 files. So let me uncomment it here. And now I'm ready with my new code. Before I commit, I will run a quick local scan for MISRA compliance. Now, Parasoft C++ test analyzes my code with a subset of MISRA C 2023 guidelines optimized for fast feedback. And in a few seconds, we'll have results. Clearly, my new code is not MISRA compliant. We have 4 problems reported for our new code. All of them are violations of new MISRA rule 12.6. The rule that was introduced with MISRA C 2012 Amendment 4, that is now MISRA C 2023. We can check the rule documentation if we need more information to understand the problem better. And looking into the code, the way our new function tries to update the atomic global variable is definitely incorrect. In the rule documentation, we can find a thorough description and examples showing incorrect and corrected code. Alright, let's fix the problem. We will need to slightly modify the function. And now we're ready to push our changes to GitHub. And obviously, we're interested in merging our new code changes with the main branch. So let's go to GitHub and create a pull request. Our pull request triggered the pipeline with C++ test MISRA C 2023 Quality Gate. In our local scans, only the most important rules are included to assure minimal delays. In pull requests, we are enforcing compliance with all the MISRA rules. So let's give it a second to finish, and our pipeline is done. We can clearly see that we are not yet ready to merge our code because additional violations were found. Let's drill down for details. C++ test static analysis results are integrated with GitHub's pull requests. Here we can see one additional finding reported. We can click here to investigate the problem. The additional issue that was caught in the pipeline is related to deadlocks, and this is a violation of MISRA C Directive 5.2, which says that there shall be no deadlocks between threads. That's another example of the guideline that was introduced with Amendment 4. And if we take a closer look, we will see that this is exactly the problem that Michał was explaining when going through his examples. We have two threads, one responsible for the periodic calibration of our sensors and one for reading the measures. And the way we acquire logs leads to deadlock. So this is really a severe problem that can potentially completely block our system and cause safety-related consequences. Since we have multiple files involved in the problem, for fixing it, it will be more convenient to download pipeline results to my VS Code. Now I locally have everything I need to fix the problem. So let me quickly get the code right. And I'm ready to push my code. Push operation will trigger the pipeline again with the MISRA quality gate. We are expecting a clear run now since we fixed the only problem. And indeed, our quality gate is now opened and we are free to merge our new code. And this concludes our demonstration. Ricardo, passing to you for a quick summary.
Thank you, Mirek and Michał. Great presentation as always. To recap, we got a bird's eye view of the MISRA C standard and how the extensions, such as the addendums, permissions, amendments, and corrigendum, tie into the standard. Michał then went into the technical details of Amendment 4, where the main subject of the document is to provide guidance on the safe use of the thread and atomic standard library introduced in C11. And Mirek demonstrated this in his demo. The fact is that not only can you integrate our static analysis engine solutions into your developer's code editor like VS Code or other IDEs, but as Mirek demonstrated, it can seamlessly be integrated into your build process or modern development workflow using GitHub as an example. And just FYI, integrations with GitLab, Bazel, and Azure DevOps also exist. So let me suggest a few call to actions. If you want to take advantage of the latest Amendment 4 update to MISRA C 2012 or employ MISRA C 2023 into your organization, please feel free to visit Parasoft and request an in-depth demo. Or on May 31st, you can actually download the C++ Test 2023.1 that supports it completely. You can also visit our website, parasoft.com, and navigate to the C++ Test product page. There you will find a Try Parasoft button. So if you have any questions after the presentation, please send us an email at info@parasoft.com. You can also find us on Twitter, Facebook, and LinkedIn. All right, let's open things up for Q&A.
Okay, as I said in the beginning, this is the time to ask your questions and get your questions answered. So on that right-hand side of the console, you can see where you can enter in your questions. And we'll answer as many as we have time for here. We have a few, and we probably have time for a few more. So first, let's see. I'm currently using MISRA C 2012 AMD2 for my project. What's the best practice in moving into Amendment 4 or MISRA C 2023? Sorry, it's a multiple part question. Should I first move to MISRA C 2012 Amendment 3? Which one of you folks wants to take that one?
I'll handle it. So The short answer is yes, you should include Amendment 3 before Amendment 4, or maybe not before, but for sure you should not skip it. Amendments are not to pick and choose. All amendments extend the core standard with essential guidelines, including mandatory and required guidelines. In Amendment 3, we have 3 mandatory guidelines. In Amendment 4, as Michał was explaining, we have 5 mandatory guidelines, and there is some number of required guidelines in both amendments, which I don't remember now. And you can't claim compliance with the standard if you skip any of mandatory or required guidelines. Now, regarding best practices, when you have a compliance process running, you're likely to have more or less even distribution of violations in your development team. I'm talking about a stable compliance process. And developers, they have their pace of cleaning the code, or perhaps you are very strict and you do not allow merging incompliant code with your stable stream. And the last thing you want to do is to blindly enable 40 plus, if we are talking about Amendment 3 and Amendment 4, 40 plus new guidelines and flood developers with the new violations. If your pipelines quality gates are very strict, developers will not be able to commit any new code before cleaning these new violations. So the recommended approach would be to do, for example, test scan with the new guidelines, analyze the report, looking at the numbers of violations reported for specific guidelines, and then progressively enable them in phases, starting probably from mandatory guidelines. And another option, static analysis tools also provide an option to silence violations reported for the code edited before certain date. So you could set a date, and any new code added after this date will require compliance with new guidelines, with Amendment 3, Amendment 4, in our discussion, and then progressively again move this threshold, this cutoff date, and include older code. Again, all to prevent flooding developers with new violations.
Excellent. All right, it was a long question, and it was a very detailed answer. Thank you. There's another one. These are really detailed questions here. So here's the next one. My team is developing C using version C11 and considering moving to C18. Does MISRA C 2023 or AMD4 provide the necessary safety and security checkers to help identify all the security and safety issues with these versions of the C coding language? Who wants that?
Okay, so let me answer that. So first of all, C18 is just a bug fix revision of the C11 version of the standard. So there are no new features there. There are some additional features that are marked as obsolescent in C18, and these are covered by Rule 1.5. And as we described in the presentation, MISRA C 2012 Amendments 2, 3, and 4, they cover all new functionalities introduced by C11, except these bound interfaces from Annex K, which are still forbidden by Rule 1.4. So yes, I would say overall, yes, MISRA C 2023, which includes MISRA C 2012 Amendment 4, it provides all the necessary safety and security checks for both versions of the standard, both C18 and C11.
Excellent. Okay. Let's see. Here's another one. Does the functional safety standard for the automotive industry mandate the use of a specific MISRA coding standard for ASIL B level functional safety?
Michał, do you want to take it, or shall I respond?
Go ahead, Mirek.
Okay, so ISO 26262 does not mandate any specific coding standard. However, MISRA is mentioned as the recommended standard. In part 6 of the standard, I believe in table 6, there is a recommendation to use MISRA.
Okay. Explain more about the tool qualification of ISO 26262.
So maybe I will also try to handle it. The tool qualification is an important part of the standard of ISO 26262, and qualification actually includes 2 steps. You have classification, where you determine the TCL level, tool confidence level, and then depending on the TCL, you have different measures for the tool qualification, and for the static analysis tools, which are usually classified as a TCL2, there are 4 recommended methods. They differ in the level of recommendations. You have either recommended or highly recommended, depending on your ASIL level. And the practice in the industry for static analysis tools is that TUV certifications are used for the tool qualification. Most of the tools on the market, including Parasoft solution, are TUV certified, and this certificate is sufficient for a tool qualification in most of the cases. For ASIL-D, in some situations, it is recommended to qualify the tool through validation, and to support this process, we provide tool qualification kit, which you can use to perform the testing in the context of the project and then qualify the tool through the validation.
Okay, excellent. All righty. Due to safety critical requirements, my organization requires a violation suppression approach that does not include editing or adorning the source code. How does Parasoft support suppressing violations?
So yeah, I'll go ahead and take that one. So really what the user is saying is that he needs to submit a deviation. So you're deviating from the standard. And you really should also, provide a reason. You need to provide a reason for that deviation, and you should get approval by the team or organization on deviating from the actual standard. So there are several ways to suppress a guideline. One of them, and this answers the question, is through an external file. So instead of the typical approach, which is to add a comment in the line of code where you're suppressing the guideline, you can apply this on an external file. It does not edit the source code in any way. And this file actually can be shared amongst other teams or the organization so that everybody's using the same common set of guidelines. And so that's, and you can do configuration management on that particular file. If you suppress it within the file, again, it is editing that source code, but it is kind of nice to see those suppressions in the code. Again, you have different options. And there's one other option, and that's through our tool, our configuration menu, you can actually turn off some of these guidelines. Not really recommended, but I mean, if you for some reason need to do that, you can. And that also leads me to kind of inform the audience that you have the ability also to merge or integrate various standards. A lot of automotive companies right now are focusing on security. And so you could, for example, adopt a MISRA C and CERT and combine the two if you want to. So you could also customize a set of your own guidelines. We have some customers that have customized, created their own set of rules, and they provide that throughout the supply chain so that everybody is on a particular set of coding guidelines. Anyways, that's kind of about it.
Okay, guys. I think that's going to do it. That was great. Excellent presentation, excellent questions, and excellent responses to those questions. I'd like to thank our three speakers for the presentation, and Parasoft for sponsoring this event. And of course, we could never do any of these things without you, the engineer. So I want to thank everyone for attending, and I hope you all have a great day.
Thank you, Rich. Bye, guys.
Thank you.
Thank you. Bye.